Hi everyone, today I'll be presenting on thermodynamics. Thermodynamics is basically the study of energy, specifically how heat and work move around and change forms. Even though the word sounds complicated, the concepts show up in everyday life. For example, when you heat up food, when your phone gets warm while charging, or even when your body uses energy from food, all of that is thermodynamics. We use thermodynamics in chemistry, physics, engineering, and even biology. So, understanding the basics helps us understand a lot of different things in science and everyday technology. Thermodynamics focuses on energy transfer, especially heat. It's all about understanding how energy moves from one object or system to another. For example, think about boiling water. Heat moves from the stove to the pot to the water, and eventually into the air. Thermodynamics helps explain why that happens and how much energy is involved. So, this field helps us describe how systems behave and predict what will happen when energy changes. There are a few basic terms we need to know before getting into the thermodynamic laws. First, a system is the part of the universe we are focusing on. For example, if we are heating water, the system might just be the water inside the pot. The surroundings are everything outside the system. In this case, the pot, the stove, the air, and the room. And finally, the state of the system refers to measurable conditions like temperature, pressure, volume, and energy level. These tell us what condition the system is currently in. Understanding this state helps us describe and predict what will happen. The zeroth law is actually very simple but super important because it basically defines temperature. It says, if object A is at the same temperature as object C, and object B is also at the same temperature as C, then A and B are the same temperature too. This sounds obvious, but it's what allows us to use thermometers. For example, when you put a thermometer in your mouth, the thermometer reaches the same temperature as your body, so it can measure it. Without this law, we couldn't trust temperature readings. The first law is all about energy conservation. It says that energy cannot be created or destroyed, only transferred or changed from one form to another. The equation for this law is delta U equals Q minus W, where delta U is the change in internal energy, Q is heat added, and W is work done by the system. A great example is a car engine. Gasoline has chemical energy. That gets converted into heat energy, which then gets turned into mechanical work that moves the car. The energy doesn't disappear, it just changes forms. The second law involves entropy, which is basically disorder. The law says that in an isolated system, entropy always increases. In other words, things naturally move towards more disorder over time. A real-life example is your room. If you do nothing to clean it, it naturally becomes messy. That's entropy increasing. You have to put in work to make it organized again. This law also explains why heat flows from hot objects to cold ones, and not the other way around, because spreading energy out increases entropy. The third law says that as something gets closer to absolute zero, which is the lowest possible temperature, its entropy or disorder becomes very small. Basically, everything becomes very still and ordered. However, the law also says that we can never actually reach absolute zero. We can get close, like in labs using special cooling techniques, but never perfectly reach it. So this law helps scientists understand extremely low temperature behavior. Thermodynamics shows up everywhere. For example, refrigerators and air conditioners move heat from one place to another. They don't create cold, they actually remove heat. Car engines convert heat energy into motion. Power plants turn heat into electricity. Even our bodies use thermodynamics. Our metabolism converts the chemical energy from food into mechanical energy and heat that keeps us alive. So, thermodynamics is not just a science topic. It explains things we use daily. To wrap up, thermodynamics explains how energy moves and changes. The zeroth law explains temperature. The first law explains energy conservation. The second law explains entropy. and why energy spreads out. The third law explains what happens near absolute zero. Understanding thermodynamics is useful because it connects science, technology, and everyday life. Thank you for listening.